All right, we're going to switch our focus to a couple of random trig problems because I had a student that said she was struggling for hours and hours and couldn't figure these out. So yeah, no, Pepe, I know this is easy for you. Yeah, I know you got an A in this. Yeah, but some people struggle with it, so she's gonna feel bad if she hears it. Yeah, so okay, let's go, Pepe. He's pretty good at this stuff, so try to stay awake. I know you get bored. Because it's really easy. Okay, so let's look at the first one. We got if x is the sine of 50 degrees, then we got to find exact answers. Yeah, draw a triangle. Draw a right triangle. That's correct, Pepe. So let's draw one. Looks good. This is our right angle. Remember, the sine of an angle, let's call this the theta angle. Or let's call this 50 because we are told it's 50. We have an angle 50 degrees. So remember, the sine of an angle in general is going to be, let's just say the sine of theta of an angle theta is equal to the opposite leg of a right triangle divided by the hypotenuse. So if this is the angle 50 degrees, the sine of 50 degrees will be equal to this height over the hypotenuse. Let's make this a right triangle with a hypotenuse length of 1, because again, you could always apply this, you can always multiply this to make it equal to any other right triangle because of similarity. So the sine of 50 degrees here will be this leg. Let's call this x. So it's going to be x over 1, which is what we have here, essentially, if x over 1 equals sine of 50 degrees then. So let's look at what this tells us about the triangle. Now, this is 50 degrees, this is 90. That means this angle up here is 40 degrees. And so we can also look at this in terms of the cosine, because the cosine of 40 degrees will be equal to the adjacent leg, which is x over 1 as well. Remember, adjacent, ADJ for short, over the hypotenuse. Probably should have wrote that before that. And whoa, what do you know? They're both the same. They're both x. And so, this was a multiple choice question, so it was actually going to be, the answer will be the cosine of 40 degrees. I believe that's answer B, yeah. Yep. Good job, Pepe. All right, let's look at another one. Number 2, we got the sine squared of theta plus the sine squared of theta minus 9d. Get my paper in order. There we go. Let's turn our attention. Okay, now a couple ways to do this. Yeah, you could just use your straight up trig values, properties. Let's look at this again in terms of a triangle. Yeah, it's always good to have a visual. Always have a visual. So we have let's erase this stuff. We get a right triangle again. Bam. All right, 90 degrees. Let's call this angle theta. And so this is 90 because we have a right triangle. 90 plus this plus that will give you all the angles. Now, let's think about this. If all the angles of a right triangle have to add up to 180 by definition, 180 is equal to that plus that, so 90 degrees plus theta plus whatever this is. Now, in reference, this will just be the remainder, or it'll be equal to theta minus 90, which is right there. So looking at it either way, because you could do 180 minus 90, so you get 90 degrees equals, again, let's just call this something else. This is probably gonna make it a little more confusing, but just in case you want to see it this way, 90 plus equals theta plus x. Let's take away theta. 90 minus theta equals x. So in either case, it gives you this angle. So you can call this x, angle x, or you can call it theta minus 90. Same thing. Let's just make it theta minus 90. Theta minus 90, because again, these three angles will add up to 180. Theta minus 90 degrees. Now, So when you solve this, you have the sine squared of this angle plus the sine squared of this angle. The only way this is going to work is if these two angles are the same. And since all angles of a right triangle have to add up to 180, then both of these are going to be 45 because that's the only way they'll be equal. So this angle is equal to this angle. This angle plus this angle have to equal 90 because we already have a 90 here. So they're both going to be 45. So theta equals 45 degrees. So we can replace this with 45. So we have the sine of 45 degrees. Oh, man, I gotta get down low. Here. The sine of 45 degrees squared, the sine squared of 45 degrees plus the sine squared of 45 degrees minus 90, so negative 45 degrees. Get out of the way. Hey, negative 45 degrees. Okay, this is our simple elementary equation we can solve. So using your unit circle, the sine of 45 degrees is root 2 over 2. So we have sine, not the sine anymore. This is replaced with root 2 over 2 squared plus, and this will be negative root 2 over 2 squared. And what is this equal to? This will be 1/2 plus 1/2, which will be, that's right, 1. Pepe, good job. Yeah, that's what I'm talking about. We got 1. Answer is 1. Nice and clean. What letter is that? B. Double B so far. All right, let's look at the next one. All right, cool. All right, let's go one. What's this? So we got sine of 25 degrees. You're right. The sine of 25 degrees times the tangent of 12.5 degrees plus the cotangent of 12.5 degrees. Erase this thing, get out of my way. Need some room. Oh no. What's the cosine of 12.5 degrees? Let's parenthesize these. Okay, so we got our tans, we got our sines, we got our cotangents. Where's the cosine at? All right, taking a break. But let's change the way this looks so that we just have cosines and sines. Remember that rule? And the cosines and sines are the fundamentals of trig because they can break everything into just vertical, horizontal legs, or x's and y's, graphically speaking. So they'll keep this as the sine of 25 degrees. And we'll open up the brackets here, times, we'll just make some big ass parentheses actually. Times, this is the equivalent to the sine of 12.5 degrees over the cosine of 12.5 degrees plus, this is going to be the cosine of 12.5 degrees over the sine of 12.5 degrees. Okay? Yeah? Iterations. Now what we're going to do is combine those so that we can have a more compact fraction or a more compact expression. And what I did essentially is made them have, well, actually, let's do this. Let's break this into the sine of 12.5 plus the sine of 12.5. You hear me? So we got the sine of 12.5 degrees. Am I going to be able to fit that there? now I'm gonna go over here. Right now, real estate over there. So we're gonna go the sine of 12.5 degrees plus the sine of 12.5 degrees all this entire group times this whole thing. All right, so let's go sine up. Cut it down low. Up plus the cosine. Over the sine of 12.5 degrees. Okay, now, what's the deal here? Hydration. We'll distribute and we'll see some canceling magic happen. This will be to that, and this will be to that. And so we get the sine squared of 12.5 degrees plus the sine squared of 12.5 degrees plus the sine of 12.5 degrees times that will cancel. So we'll just have a cosine of 12.5 degrees there. And this will be over the cosine of 12.5 degrees. Yeah, and now we just distribute that to those ones as well. Same thing again. So we have plus sine squared of 12.5 degrees over the cosine of 12.5 degrees. Plus the cosine of 12.5 degrees, because those sines of 12.5 degrees will cancel. So plus the cosine of 12.5 degrees. Okay, guys. Now, if you notice, we have two of these, and two of these. So we just double them all up. So let's go up here. So we can just go 2 times the sine squared of 12.5 degrees over the cosine of 12.5 degrees. That'll go away. It'll be away. Then we have plus 2 times the cosine of 12.5 degrees. And then we end up with this, and we can just have a common denominator here. Make this multiply this by the cosine of 12.5 degrees. And this will be squared. Then on top, you'll see that we have sine squared plus cosine squared times 2. So 2 times 1 over the cosine of 12.5 degrees. And I didn't write the multiple choice answers up here, but this ends up just being something we can't simplify without a calculator, because it'll just be 2 over the cosine of 12.5 degrees. So it won't be any of those multiple choice answers shown. There'll be none. All right, and just one more, right? Come on, Pepe, you can do this. Oh, it's easy. I know, I'm sorry, Amy. Yeah, I know. Right, this one's the easiest one, actually. It's so easy that I'll teach it to my the kindergarten kids that come by. So we got, clear this up. The sine of 2 pi over 5. Sine 2 pi over 5, 2/5 pi, plus the sine of 4/5 pi, plus the sine of 6/5 pi, all the way to 8/5 pi. Oh, no time for that. Plus the sine of 8/5 pi. Okay, so here we can just add up the expressions inside the parentheses. So 2, 4, 6, 12, 20. So we got the sine of 20/5 pi. What the heck is wrong with this marker? We got the sine of 20/5 pi, which is just the sine of 4 pi. What the heck? This marker. And that's just 0 because that's just the start of the unit circle. 0. Bang. You know, the unit circle is like you go like that. You start here, that's 2 pi. You go around. That's, 0, 2 pi. You go around again, bang, bang. That's also angle of 4 pi. 0. The coordinates here are 1, 0. The sine is the y coordinate essentially on a unit circle. So we're done. We got it. Yeah, that's what I'm talking about, Pepe. Good job. Really easy. Yeah, I know. All right. Thanks for watching. Make sure you subscribe. Tell your parents, tell your mom, tell everybody. And I'll see you guys next time. Bye-bye. All right. Bye, guys. Thanks for watching.